Yesterday's lesson and assignments, I hope that there's a question in your minds, and I hope that question is, what the heck is a critical value for? Like, what are these critical values about? What are these critical numbers about? And I'm hoping to answer that by the end of this video. So the idea in this video is, and I think this is something we did in chapter 2 when we first did derivatives. The idea here is I'm giving you a picture of, and this is super important, this is a graph of the derivative. So somebody already took the derivative of some unknown function f, and this is the picture of that derivative, right? And the 7 questions that I'm going to ask here are, I want to know if the original function, if f of x, is increasing or decreasing at these 7 values of x. Right? So hopefully you remember from yesterday's lesson, the whole idea is a function is increasing if its derivative is positive, it's decreasing if its derivative is negative. Right? So our first question is basically, what about negative 2? Right? Effectively, the question is, what is f prime of negative 2? Well, you're in luck. I happen to have a picture of f prime of x right here. So if I go back to negative 2 and follow up to here, I notice that f prime of 2 is 6. Because that's positive, I can tell the original function is increasing. Right? What about at x equals negative 1? Right? Well, if I go back to negative 1 on this graph of the derivative, this thing is up at, I guess that's probably positive 1. To be honest, it doesn't really matter to me. What's important is that f prime of negative 1 is greater than 0. It's positive. That means the original function is increasing. Right? I want you to pause the video, go through and figure out whether the function is increasing or decreasing, whether the function is increasing or decreasing at these other 5 values. So do that now. So you should have found that f prime of 0 is, down here at negative 2. Because it's negative 2, the function is decreasing. At 1, it's down here at, negative 3 or so, which means the original function is decreasing. At 2, it's again down here at, sort of negative 1. I'm sorry, negative 2, which means the function is decreasing. When I get over to 3, I'm up here at a value of positive 1, so the function is increasing again. And at 4, I'm up at, positive 6, which means the function is increasing again. So yay, we've got these things, fantastic. The next question I want to ask is, can you tell me what the critical numbers, the critical values of f of x are? I'm going to try and scroll this up some. Can we find the critical values of f of x? And I hope that you remember from yesterday, how do we find critical values? Critical values are supposed to happen when the derivative is undefined or equal to 0. Well, good news. Here it is me saying it again for the 5th time. This is a picture of the derivative. Where is this thing equal to 0? Well, this thing has a height of 0 right here and right here. The critical values are, and I'm going to have to estimate here because these aren't exact things, our critical values are approximately negative 0.75 and positive, we'll call it 2.75. Those are my critical values. Now, I'd said by the end of this video I wanted you to know what the critical values were about, and so now I'm going to do something crazy. I'm going to try and draw the original function based on this thing, right? And this is going to be a little bit wacky, but bear with me. Right? I'm going to use a different color here. We just said that the original function was going to be increasing at negative 2. And in fact, it's interesting. Think about this statement right here. This says that the derivative is 6. The slope is supposed to be 6. So at negative 2, my original function has a really, really steep slope. Right? By the time I get over here to negative 1, my slope is only positive 1, so my slope is sort of like, it's less steep now, right? What happens when I get to this point right here? What is the derivative right there at negative 0.75? Well, because it was a critical value, the derivative is 0. So that means the slope of the tangent line is 0. It means this function leveled off, right? Then what happens? Here and here and here and here, like tell me about all of these derivatives. Every single one of these values is negative. Because they're below the x-axis, the derivative is negative. That means this function starts to decrease, and decreases and decreases and it keeps on decreasing until I hit this value. Right here, the derivative is 0 again and levels off. And then what happens past that? These derivatives, these values of the derivative function are positive, more positive, more positive, more positive. That means my slopes are a little bit positive, more positive, more positive, more positive, and it just goes up like that. Well, it doesn't curve to the side like that. I mean, it's terrible. Kind of goes up like that, right? So the big, huge question, what are critical values about? What's the whole point? The whole point is that when you have a critical value, I'll use red this time, when you've got a critical value, that tends to indicate that there was either a maximum or a minimum value of the original function. It doesn't always, there's some exceptions, we're going to talk about those in the later videos, but the whole idea, the thing that I want to sort of end this video with, is that critical values are the locations, I suppose I'd say the x value locations of potential maxima and minima. Right? So in other words, if you ever want to find the maximum or minimum value of a function, find the critical values, because that's the only place you're going to find them. The only place you'll ever find a maximum or minimum is at a critical value. And so I'm going to get into that in the next video. The next one is going to be a lot more about procedure, about how we find these maxes and mins. So stay tuned for that one. I'll see you there.